All right, so we have this fantastic drawn diagram that I'm going to do the best I can to have here. We have a point here, point here, point here, here, here. 5.1 notes. So you're going to see at the top a wonderfully drawn, really bad representation of something. All right. So friends, I have no idea what this function is. I mean, it's just a drawing. I know there's an endpoint at G, and then a few things that we could label on here. Like this is an endpoint. Okay, shows it doesn't keep going. This is called a local max. This is called a local min. Okay, and says show where it's increasing, decreasing maxes, mins, horizontal points of inflection. Okay, this right here is called a horizontal point of inflection. Now, in order to find a horizontal point of inflection, you won't have to do it here and here, but basically you take the first derivative, then you take the second derivative. When you set the second derivative equal to 0, that finds you horizontal points of inflection. We're not going to have to worry about doing that in here. It's kind of where a graph goes from doing something to something else. So let's talk about, first thing, let's talk about where this graph is increasing. So we'll do it in red. So this graph is increasing here to here. Okay, so it goes right through the horizontal point of inflection. So basically, it's increasing from B to F. And I'm not too concerned if you can do square brackets or round brackets. If it was a multiple choice, I would not give you rounded brackets and then square brackets. It's just one or the other. Don't panic on the knowing of it. Okay, so that's where it's increasing. Where this graph is decreasing, let's pick ooh, I like this purple. I'll go purple. Where it's decreasing is here. So it's decreasing from negative infinity because there's not an endpoint all the way to B. And we can make that a square bracket. And it's also decreasing from F to G.
Hello.
Hi, what you got here? Okay, we'll take care of this.
Okay, see ya.
What you do? What you do? I'm playing with matches again. You got a little chuckle on your face. So from F to G, it's decreasing. All right, so what it really just means when you're talking about increasing or decreasing is where the slope of any of the tangent lines would be increasing, they'd be positive, decreasing, they'd be negative. At point D, it's called a horizontal point of inflection. So sometimes they will say it stops increasing or decreasing there. Sometimes it just kind of continues. But we're going to draw our F prime chart off of this. Okay, so an F prime chart. All right, so I want to add a few items to this. I'm going to call this point Z. I'm going to call this point Y, and then we have point G. Okay. So now I think we can kind of talk about what this is doing. So we have point B that's important for us. We have point D that's important for us. And we have point F. Okay? So To the left of B, in the purple region, so from negative infinity to B, it's decreasing. It would have a negative slope. From B to D, so let's do this. And I'm going to try something, and we're going to see if this works. So here it's negative slope. Anywhere along there's negative slope. If I get into this region here, and this region here, what it basically happens is we have a positive, and then we have a positive. Okay, so something that happens at D, if you see just a positive happening, that means there was some sort of point of inflection, meaning if I was finding the slope as I was going through, it was taking place. So, highlighter and highlighter. And then the last region of our graph is negative, because the last region of our graph is talking about blue, this region here. Okay, so things that you should know about point B. If I just gave you that F prime line, this is going to mean, if you didn't have the graph to look at, this means right here, because your signs change directions, it goes from a negative to a positive, this means that we had a local minimum value. This point right here at point F, where the signs change from positive to negative, this means we would have had a local minimum, or a local maximum, excuse me. When you have no sign change, but you have something indicated in between, this means it was a point of inflection. Okay, so it's kind of a newer concept to think about with the graph. So what would happen is we might give you that very bottom diagram, the F prime chart, and we'd say, hey, kind of try and figure out what the shape of our object would look like. And so what you'd basically do is you'd say I have B, I have D, and I have F. So I know the graph's doing this, I know it's doing this, I know it's doing this, and I know it's doing this. Okay? So that's basically what the graph is doing. Now, some people might take this region here and say it's doing this, and then it's doing this. So you're showing that it changes directions, but both of those would have positive slopes if I was just finding the linear equation. Okay? So a little bit different thought process when you're looking at it. Okay? All right. So let me see. Okay, we do that. So can I move down to the bottom for they want the F prime chart based on the graph? Can I move?
Yeah.
Some of you don't have books out. What happened? What did I do wrong? Was it something I said or something I did? Did my words not come out right? Though I tried not to hurt you, though I tried. But I guess that's why they say every rose has its thorn. All right. So they're going to call this A. They're going to call this B. Call this C. Okay, so if I were to make my F prime, so that's the given an F prime chart for the following. So here's the graph, so we want to make the F prime chart. So I'm going to go A, B, and C on it. Okay. Typically, you could list an X value. So I mean, technically, the C value is 4, the B value is at 1, and the A value is at -1. But then you could say, okay, so what would you think the slope in this black region of our line would be, positive or negative? Positive.
Yeah.
And then from A to B right here, what do you think it would be?
Negative.
Negative. Okay, so what can you guarantee because it went from positive to negative, what can you guarantee me right now about point A? It's a local what? Local max. Okay. And then point B to C. So I have this, and then I have this. So it appears that both of those are positive and positive. Okay, so let's go in between here. If I go from A to B, it's negative. From B to C, it's positive. So what can you tell me about point B? Is it a local max or min? Local min. And being the sign didn't change place from B to C and then from C to infinity, what can you tell me that point C would be? Is what kind of value? It's not a local max or a local min. It's a point of inflection. It means it inflection. It means it changed direction, but it didn't change from being a positive slope to a negative. It went positive slope, changed a little bit more direction, kind of flattened out for a moment, and then it became positive slope again. Okay? So that's basically what a sine line looks like. Okay? Can I go to the back side? We ready? We good in the hood? All right, so now we're going from a sine line. We have 1, we have 3, we have 5. This goes from positive to negative. This stays negative and goes positive. Okay. So a positive slope looks like this. Agree? My arm?
Yeah.
And a negative slope looks like this. My arm?
Yeah.
So what happens between going from a positive slope to a negative slope? Local. So local max. Local max. If the signs stay the same, what happens there at 3 then? Point of inflection. POI. Okay, and then if I go from a negative slope to a positive slope, negative to positive. Okay, local min. So if we wanted to draw kind of what our graph might look like, I have 1, I have 3, I have 5. So this graph is doing this. It's doing this. It changes direction a little bit. And it is that. So that's not exactly what the graph looks like, but this is kind of giving you a bird's eye view. This is positive, negative, negative, positive. Okay? So again, you don't know exactly what the graph is going to look like. You just have some sort of general idea that the shape might be. I'm not sure how high or low goes in the y direction to get our actual values, but I do know there's some things that are taking place based off of that. Okay, so where are we at? We're doing good? Cool, we can keep going. All right, so I just want to teach. Can I move off this screen?
Yeah.
All right, example 2 on that back side. We have a -3, we have a 1, we have a 4. We know it's negative here, we know it's positive here, we know it's positive here, we know it's negative here. So a negative slope to a positive slope. What takes place right here at this 3? Local min or max or point of inflection? Local min. If we don't get a sign change at 1, what takes place? Point of inflection. And then I go from a positive slope to a negative slope. Local max. So if we wanted to take a gander at what this is going to look like, we have -3 down here, we have 1 here, we have 4 here. What is this graph going to look like? It's going to do something like this. It's going to do something like this. It's going to change direction but stay as a positive slope all the way to 4, and then it's going to go like that. So that's kind of the shape. Again, I don't know exactly what it's going to look like. It'll probably be nice smooth contours to it, but we just kind of have some jagged things. Oops, and I made a mistake. This should have come all the way to here, and then this should have went to here. Get rid of that. Okay. All right. This is an F prime chart. It's a derivative chart. So the derivative chart, when you know positive, negative, and how you would get those positive or negatives is you honestly could take a number to the left of -3 and plug it in, and you can see it's negative. You can take a number between -3 and +1, you plug it into the original, it comes out positive. Plug between 1 and 4 in, plug that number in, it's going to come out positive. If you plugged 1 into the original, it would actually come out to 0 into the derivative, and then so on and so forth. All right. Roots. So if we were to graph this, and I know we have Desmos in our back pocket, so we can always utilize that if we wanted to. But we want to ask us this. What are our roots? Okay, that means I'm going to take this, set it equal to 0, and factor it. So I factor it out in x. So now that x is equal to 0, and x squared minus 12 equals 0. So solve this. So I get x squared equals 12. Take the square root of both sides. Don't forget the plus minus. So you get root 12. Okay, yeah, you could rationalize root 12. You could say it is this. It's 2 root 3. You can leave it as root 12. I'm not too concerned. Okay, so there's our 3 roots. We have 2 here and 1 here. Okay, the interval where this is increasing. Okay, so we want to think about what this graph is doing. So what I want to do is I take my function. I want to take the derivative of it. So the derivative is 3x squared minus 12. So that's the derivative. Set 3x squared minus 12 equal to 0. So I get 3x squared equals 12. X squared equals 4. X equals plus or minus 2 if I solve that. Okay? I think we're okay. So intervals where it's increasing, intervals where it's decreasing. So we have an awful lot of information. Our original function, we have roots at 0, and then 2 root 3, 0, and negative 2 root 3. Those are roots. So the graph has to come down to negative 2 root 3 or go up to it. It has to somehow change directions and go through 0. It has to somehow change directions and go through 2 root 3. So those are my roots right now. Okay, roots of the original. And then if I look at it and I say, okay, what's taking place at this? These are the answers that come from the derivative. This is where the derivative is equal to 0. So at 2 and at negative 2, this is where the graph is a max or a min, local max or min. Okay, it changed from being positive to negative. Okay, so then we just kind of have to think about this. Now, there's different ways that you could go through and kind of think about this, but let's pick a value like way out here. Let's pick, say, negative 10. If I plug negative 10 in to the original, negative 10 to the third power minus 12 times negative 10, that's going to give me negative 1,000 plus 120. So that's definitely a negative answer. Okay? Negative answer means it's happening down here. So this graph is basically doing this. Looks something like this. I don't know how high or how low it's going to go, but at the 2 and at the negative 2, that means it was a change of direction. So this means that this is a local max. This is a local min. And if I were to make my sine chart off of this, I could plug in -2 and I could plug in +2. And this would tell me that the slope of the tangent would be negative here, or excuse me, positive here, negative in between, positive here. Okay, that's basically what's taking place with this problem. All right, so the intervals where it's increasing, this is increasing here. So it's increasing, this is showing us that we have a local max. So it's increasing at 2 spots. It's increasing from -infinity all the way to -2. And then it's, so positive to negative, negative to positive. And then it's increasing also from 2 to infinity. So these are the 2 spots where our graph would be increasing. In between the 2 is where it's decreasing. So it's decreasing from -2 to 2. And I don't necessarily know if I have a point of inflection that I'm going to deal with on this one. Again, I guess I could take the second derivative. Second derivative would come out to 6x at 6x equals 0. So 6x equals 0, divide by 6, x equals 0. So 0 might be a point of inflection. So we're just going to kind of put, this might be a point of inflection. So technically it would have went negative, negative like that. Okay? But again, we don't have to worry about the second derivative. All right. So my friends, would you try worksheet 5.1, try 1 through 4 only. And I'll give you, if you give me an honest try tomorrow, I'll make sure I'll put points in for you. Deal?